Dear students of third secondary schools mathematical section, I have the pleasure to meet you today to introduce a new lesson in dynamics, which is Newton's second law. Now let's go to the definition of Newton's second law. The rate of change in momentum is directly proportional to the impressed force and takes place in the direction of the straight line which the force acts. When m is constant, and since F is in direction of A, then MA equals F. The mathematical formula given before can be regarded as sum of forces in direction of motion minus sum of the forces anti-direction of motion equals MA. Units of force. Dyne equals gram centimeter per second square. Newton kilometer meter per second square. And the relation between the Newton and the Dyne is that of Newton equals 10 power 5 dynes. And kilogram weight is 9.8 Newton, but gram weight is 980 dyne. Now let's go to the following example. A bullet of mass 49 gram hits a vertical wooden barrier while moving horizontally with the speed 100 meters per second. If it comes to rest after going through the barrier 50 centimeters, find the resistance of wood to the bullet. How much will be the velocity of the bullet when it comes out of a similar barrier whose thickness is 25 centimeters? Solution. The given is U equal 100 meters per second, S equal 50 centimeters, which is half meter, and V equals 0, and M equal 0.049 kilogram. Using the rule V squared equal U squared plus 2AS, therefore V equals 0, U equal 100 all squared plus 2A times S, which is half. So by calculation we get A equals negative 10,000 meters per second square. Using MA equals negative R, therefore 0.049 times negative 10,000 equals negative R. Then R equals 490 Newton, which is 50 kilogram weight. But since V squared equal U squared plus 2AS, therefore U squared equals 100 squared minus 2 times negative 10,000 times 0.25. Therefore, V equals 50 root 2 meter per second. And now, let's go to another example. A body is left to fall from the top of an inclined plane whose length is 10 meters and the height is 2 meters. In the same instant, another body is thrown from the bottom of the incline up with a speed of 50 or 5 meters per second. Find where and when the two bodies collide. Solution. As you see in the figure, AB is the inclined plane of height 2 meters and its length is 10 meters, and we resolve the magnitude of the body into mg sine theta down and mg sine theta up, and S1 is the first distance, S2 is the second distance, and C is the point when they collide. For the falling body, mg sine theta equals ma. So after we cancelling m with m from the left and the right hand side, we get A equals 9.8 times 2 over 10 equals 1.96 meter per second square. But for the ascending body, negative mg sine theta equals ma. Therefore, A equals 9.8 times 2 over 10, which is negative 1.96 meter per second. After they collide, they meet at C, where AC is S1 and BC is S2, where S1 and S2 equals 10 meters. So S1 equals half AT squared, and S1 equals half times 1.96 T squared, and its S2 equals UT plus half AT squared equals 5T minus half times 1.96 T squared. Therefore, S1 and S2 equals 10, then 5T equals 10 means T equals 2 seconds. So S1 equals half times 1.96 times 4 equals 3.92 centimeter. Now let's go to another example. A train of mass 56 tons moves along a straight line with uniform velocity of magnitude 88.2 km per hour. During the motion, the last wagon of the train, whose mass is 7 tons, is separated. It declares unit it came to rest. Given that the magnitude of the resistance to train equals 40 kilogram weight per ton, find the magnitude of the driving force of the train. Number 2, the time taken by the separated wagon before it comes to rest, and the speed of the train at this moment. Solution. Now, as you see in the figure, the train whose force of engine is to the right F and the resistance is to the left R, and the mass of the train is 56 tons. Number 1. R equals 56 times 40 equals 2240 kilogram weight. So F equals R. Then F equals 2240 kilogram weight. Number 2. R dash to the left and the mass is 7 ton, then negative R dash equals MA. Therefore, negative 7 times 40 times 9.8 equals 7,000 A. Therefore, A equals 0.392 meter per second square. Therefore, U equals 88.2 times 5 over 18, which is 24.5 meter per second. Therefore, U or V equals U plus AT, then 0 equals 24.5 minus 0.392 T. Therefore, T equals 62.5 seconds. Then 2240 minus 49 times 40 times 9.8 equals 49,000 A dash. Then A dash equals 0.056 meter per second square. Therefore, V equals 24.5 plus 0.056 times 62.5 equals 28 meter per second. A particle of mass 2 gram is moving under the effect of the force F equals 8I plus 4J. The position vector of the particle at any moment is given by R equals AT squared plus 5I plus BT squared plus N in direction J, where T is the time in seconds and R in centimeter. Find the values of A and B. Solution. Since R equal AT squared plus 5 in direction I plus BT squared plus N in direction J, therefore S equals AT squared I plus BT squared J. Then V equals ds over dt equals 2ATI plus 2BTJ. Therefore, A equals dV over dt equals 2AI plus 2BJ. Then number 1. Since MA equals F, therefore 2 open bracket 2A in direction I plus 2B in direction J, close the bracket, equals F, which is 8I plus 4J. Then 4A equals 8, therefore A equals 2. Then 4B equals 4, then B equals 1. Now let's go to a new example. The position vector of a particle is given as R equals t cube over 24 plus 2 over t plus 3 plus 9 in direction k, where k is a constant unit vector and r in centimeter and t in second. If the mass of the particle is a variable and is given by m equals 8 open bracket t plus 3 all squared, then find the vector force at the moment when the particle is at rest and its magnitude. Solution. Since r equals t cube over 24 plus 2 all over t plus 3 plus 9 in direction k, then s equals t cube over 24 plus 2 all over t plus 3 in direction k. Then v equals the derivative of t cube over 24 is t squared over 8 minus 2 all over t plus 3 all squared in direction k. Therefore, mv equals 8 times t plus 3 all squared times t squared over 8 minus 2 all over t plus 3 power 2 in direction k equals t squared times t plus 3 all squared minus 16 in direction k. Therefore, since f is the derivative with respect to time to mv, therefore f equals d by dt of t squared times t plus 3 all squared minus 16 in direction k. Therefore, f equals 4t cube minus 18t squared plus 18t in direction k. When v equals 0, therefore t squared over 8 minus 2 all over t plus 3 all squared equals 0. Then t squared times t plus 3 all squared equals 16. Therefore, t times t plus 3 equals 4. Then t equals 1 second. But when t equals 1, f equals 4 times 1 cube plus 18 times 1 squared plus 18 times 1 in direction k, which is 40k. Therefore, f equals 40 dyne. The magnitude of f equals 40 dyne. Now, let's go to another example. A car of weight 8 tons is moving on a horizontal road against a resistance whose magnitude is proportional to the square of its velocity. If the magnitude of the resistance is 7.5 kilogram weight per ton of the car's weight, when its speed is 45 kilometers per hour, find the magnitude of the engine force given that its maximum speed is 135 kilometers per hour. If this car is pulled an ideal car whose weight is 5 tons on the same road, find the magnitude of the common acceleration of the two cars, given that the resistance become 12 kilogram weight per ton. Solution. Since r varies as v squared, therefore, as we said before, r1 over r2 equals v1 squared over v2 squared. Therefore, 60 over r2 equals 45 squared over 135. Then r2 equals 540 kilogram weight. At maximum speed, F equals R2 equals 540. But since F equals MA, therefore F minus R equals MA. Then 540 minus 12 by 13 times 9.8 equals 13 times 10 power 3 A. Therefore, A equals 0.289 meter per second square. Now, let's go to deal with another title, which is the third law of Newton, or Newton's third law. It states that for every action there is a reaction, equal in magnitude and opposite in direction, and acts on the same line of the action. Example: a man of mass 70 kilogram stands on the floor of an elevator, accelerates vertically by 245 centimeter per second square. Find the pressure of the man on the bottom of the elevator in each of the following cases. Number 1, the elevator is moving upward. Number 2, the elevator moving downward. Number 3, the elevator is moving uniformly. Number 4, the elevator is moving down with A equals G, the gravity. Solution: as you see in the figure, the man is of weight W, and the reaction is upwards R, and acceleration is upward. Number 1, the elevator moving up means MA equals R minus W. R upwards and W downwards, so R minus W. Then MA equals R minus MG, so R equals M times A plus G. So R equal M times A plus G in case of elevator moving upwards, but in case of moving downwards, the sign will be negative. Notice that. So R equals 70, open bracket, 2.45 plus 9.8 equals 87.5 kilogram weight. Then P, the pressure, equals 87.5 kilogram weight. Number 2, in case of the elevator moving down, MA equals W minus R. W first minus R. Then we replace W by Mg, so MA equal Mg minus R. Then R equals M times G minus A equals 70 times 9.8 minus 2.45 to get the final answer 52.5 kilogram weight. Therefore, the pressure here is 52.5 kilogram weight. Number 3, the elevator moving uniformly. Moving uniformly means R equal W, equal also the pressure, equals 70 kilogram weight. The last required is when A equals G. Since R equals mg minus A, and since G equals A, therefore R equals 0. Okay? This case is called weightlessness. Weightlessness. Now let's go to another example. A man stands on a pressure scale on the floor of an elevator moving vertically. The ratio between the readings of the scale when it accelerates up with A equals k meter per second square, and when accelerates downwards with A equals 3k meter per second square is 9 to 5. Prove that k equals 1 over 8 g, and if the mass of the man is 64 kilogram, find the scale reading on the upward motion. Solution. In case of moving up, R1 equals mg plus k, and this is equation number 1. In case of moving down, R2 equals mg minus 3k, and this is equation number 2. Divide 1 by 2, so R1 over R2 equals g plus k all over g minus 3k equals 9 over 5, then 5g plus 5k equals 9g minus 27k. Therefore, 32k equals 4g, therefore k equals 1 over 8g. When m equals 14 kilogram and from 1, therefore R1 equals 14 times g plus 1 over 8g equals 15.75 kilogram weight. Dear students, this example leads us to the end of our program today, and until we meet again the next week at the same time, I hope you enjoy our lesson today. I hope you all success. Thank you and goodbye.